Well, this is a CPU. That's a proper 8-bit CPU, a Z80 from, I don't know when, from like the late 70s, early 80s. And there it is, an 8-bit CPU. But that's a real CPU made in a factory properly. What I want to do is make my own CPU on some sort of PCB. So what I've been doing is I've been prototyping some bits and pieces for a CPU that I'm making myself. And what I've done so far is made about a third, well, not even a third of it, it's a prototype of about a third of it. So I decided that the CPU I was going to split into 3 pieces. The ALU, which does the maths, the register transfer section of it. This is the register transfer machine board, which contains the registers and the internal bus. And then you need some sort of control unit to do the microcode and the sequencing and clock pulses and all sorts of control bus stuff. So I'm going to split it into 3 parts, and I've made this prototype. It's just an early prototype, just to try out a few ideas. There's no way that this is going to be part of the finished thing. So I thought what I'd do is finish soldering some chips into here. You can see there's some gaps. And while I'm doing that, I'll just briefly go over some of the things that I've been thinking about while doing this. Okay, so I need a couple of sockets first for the next pieces of it. I've got one more register to implement over here. No. Bend that back. Oh. I've got one more register to implement over on the right hand side. I'm starting to think I've already implemented enough really to make me realise that this prototype isn't going to take me very far, but I think I'm going to finish it off just to experiment with a few bits and pieces. Okay, so soldering iron on standby. Here we go. Wow, I don't know why. I'm not sure if I've got my soldering iron too hot, but I do get a lot of smoke out of this thing. Maybe it's the type of solder. And maybe I'm just putting too much solder on. So I first got interested in this project because I was watching a YouTube video by Ben Eater where he was making his own CPU on solderless breadboard. I thought, what a great idea that would be. I'd love to do that. I'd love to learn more about CPUs, how they work, how they're manufactured, how they're put together, and what simpler way than solderless breadboard. How fantastic. So I had a go at that. Have I got a piece of that? Anything like that anywhere? Well, this was some part of it. In fact, that's why I was looking at the ALU part of it. So there's an Arduino there to interface that to the PC, and I tried making an 8-bit ALU and having a little play around. What I discovered was it involves a lot of cutting of wires and poking them into little tiny holes in solderless breadboard, and when you do that, they pop back out again, and you get stray resistance and stray capacitance. It was a bit of a disaster, and although I got something working, I found it was really annoying, and I'd put it away in a cupboard. I'd come back to it a bit later, and it would not be working anymore, and it wasn't very reliable. So then I tried making things on a kind of Vero board, you know, like the strip board stuff, which at least was soldered in, but it still involved a lot of cutting of wires, which I didn't really enjoy doing, and it's very hard to get a lot into a small space on strip board, so I could see that it was going to turn into some monster project spanning several square meters, and I didn't really fancy that. And then I discovered about how to make PCBs and get them manufactured really cheaply. So this PCB I've got here, for example, I got 5 of them made for £6, including shipping from China, so they cost about £1 each, even though I only want one of them. And so it's actually very, very good, you know, it's very high quality, really cheap. So it seems to me that if I solder a bunch of stuff onto this, play around with it for a while, learn about how its good points and its bad points, and then abandon it basically and go on to some, like prototype version 2, I still think that's better than making a prototype on solderless breadboard, which would take me, I think, several times as long. So my interest in this initially was just to make any kind of CPU really, and then I started realizing that if I do put together a CPU and it works, I'll have a CPU that's completely bespoke, that runs my own assembly language that I will have to make up, and that there's no software for anywhere in the world that can run on it. So I thought that is actually going to be pretty boring, because there's nothing worse than a computer with no software to run on it. It's not really the point of a computer, is it? You want to be able to play games on it or something. So I was thinking, how could I make something that would be interesting when it was finished and I could actually do something with? So for example, I did a project recently where I made a CPM computer, and that is really fun because you make the computer and then there's a whole world of CPM software sitting around on the... There's a whole load of CPM software sitting around on the internet that you can use. You can run on it, and it's actually really good fun. So I don't want to make a CPU that's got no software. So I thought, how can I make a CPU that you could find some software for somewhere and run it? And there was a few options. One is to emulate, or well, it's not really emulate, but copy an existing CPU. So I could, for example, copy the Z80 CPU that we were looking at a second ago. But I was thinking, if I copy another CPU, like the Z80 CPU, then it's going to be quite complicated, because the Z80's got a stacked load of instructions. Even a simple CPU like the Z80's got a stacked load of instructions. So then I thought maybe I should create my own bespoke assembly language, but develop something like a C compiler, so I could compile into my language. So compile C into my assembly language, and then use an assembler to assemble my assembler that I'd have to write to assemble my assembly language into machine code for my CPU. But I think that would just turn this project into a massive software development project. Plus I'd have to actually learn how to write my own C compiler. Could be tricky. So I haven't really fancied it. So then I was thinking, could I make a CPU that ran a reasonably high level language? The reason I'm trying to not just make it low level assembly language is because that's a right nuisance to work with. So I thought, could I create a CPU that ran a higher level language? I mean, is it possible to create a CPU that runs Forth directly as its base language, and you don't even need an assembler or a compiler? Well, I suppose you'd need some sort of compiler, but you'd compile it straight to C somehow. I don't know. I couldn't work that out. But I did find out that you can do that with a stack machine CPU and run Forth, the programming language Forth, as the native language of the CPU. So I got quite interested in that, and I started looking up how I could make a CPU that runs Forth. And I saw someone had already done that actually. They've made a CPU that runs Forth as its native language. The only problem with that is that Forth is a write-only language. So you write a program in Forth, you look at it again 2 weeks later, you can't work out what it actually means. It's pretty much gibberish in the first place, because it's all full of these very short instructions like nop and swap and drop. No, not nop at all. That's assembly language, isn't it? Drop and dup and all this sort of. It's a very terse and difficult to understand language. Let's just put it that way. So I didn't really like the sound of that, of doing it in Forth. So then it finally dawned on me what I need to do, and I've made that decision about what I'm going to do, and I'm going to go in this direction from now on, which I think will make the whole thing clearer and easier for me to work with. And I think will also give me some sort of goal or some kind of target that's quite easy to, or at least achievable. And that is that I think I'm going to make my CPU to be like the 6502 processor, with the aim being that it would be byte compatible with the 6502 processor. So you'd be able to get some code written in 6502 assembly language, assemble it, and you could run that code, that assembled code, on either my CPU or a real 6502, which I think would be a lot of fun. And there's plenty of 6502 code laying around on the internet that I could then download and play around with. Let's get some chips in there. Yeah, so the more I think about this 6502 idea, the more I like it, because there's plenty of 6502 source code around, absolutely tons of it. There's quite a few people interested in the 6502, which means that they might actually be vaguely interested in what I'm doing, rather than me just doing something completely in isolation that no one's remotely interested in. I could also, I had a Commodore VIC-20 when I was young, so and I really enjoyed it. I learned 6502 assembly language, and I'm pretty certain I wrote an assembler on my Commodore VIC-20. I did. I wrote an assembler on my Commodore VIC-20. So I do know about 6502 assembly language. I've got some kind of history with it. I enjoy it. It's nice and simple. And also, it's a simple CPU. It's a much simpler CPU than the Z80. So I think that would definitely be the best solution, because then I can try writing. Oh, what have I done? I can try writing stuff for the 6502. That doesn't get that's better. I can try writing stuff for the 6502, assemble it, run it on some sort of 6502 emulator, or maybe construct a board with a real 6502 on it and run it on there, and then I can try running it on here and see if I get the same result. Right, so what have I done then? I've added one more register in here. So if you watched any of the previous videos, you'll see that I've been transferring data into register 1 and into register 2. I've been using register 4, which is a memory pointer pointing into this RAM chip here to store stuff in the RAM and read stuff back out of the RAM. So now I've implemented register 3, but it's a slightly different register because it's got this ALU. I jokingly call it an ALU, composed of two quad NAND gates there. And so the value of register 1 and register 2 passes through this ALU here. And register 3 isn't connected to the bus in quite the same way as the other registers. So the input to it can only come from the ALU, and the output goes back to the bus. So you can do a sum from register 1 and 2, well, it's actually a NAND operation, and get the result into register 3. So I've implemented an ALU that only does one function. Normally an ALU would sort of NAND, NOR, exclusive OR, add, subtract, shift left, shift right, but I just wanted one of those functions. And NAND is apparently the universal logic function that you can build all the others out of, but you'd have a hard job doing it, I think.